Hello, today I'm going to talk about a well-known snake. Some of you might remember my talk at BotConf 2018 in which I presented the evolution of snake, which is another name for the infamous Turla APT group. And I'm back to present what changed since 2018. In the past 2 years, we investigated several incidents involving Turla in high-profile organizations. I'm Mathieu Faou, a malware researcher at ESET, and my day-to-day job is to track APTs using the ESET telemetry. First, who is Turla? According to this recent tweet from the US Cybercom, Turla is allegedly a Russian-sponsored APT. They've been known for more than 10 years with, for example, the compromise of the US military in 2008 using the infamous agent.ptz worm. More recently, they have compromised the German Foreign Office and several mailboxes belonging to the French military. These are just a few public examples, but most of their attacks are not public because Turla mainly target organizations that don't talk about cybersecurity issues. In the past years, the main targets we observe are Ministry of Foreign Affairs in Europe, governments in Central Asia, diplomats in the Middle East, diplomats in South America, and some private company in Asia. So for Asia, we don't have first-hand information, but this is based on submissions I saw on VirusTotal. Attackers' motives is important when it comes to defending against a specific threat actor. To our knowledge, Turla conducts espionage operations and is interested in private documents of its targets. Contrary to other groups, they do not push miners or ransomware. Thus, it is likely that Turla will stay undetected for months or even years. They generally collect documents in bulk, meaning that it's not possible to determine the subject of interest just by looking at the exfiltrated data. This is an example of a MySQL query that Turla operators were performing at regular intervals to collect recent documents in a central database. This shows that they were interested in docx, and some specific PDF files. This is another example that we found at another organization. In that example, they use the WinRAR application, and they are collecting documents such as doc, PDF, or Excel files from specific folder and the recycle bin. When it comes to compromise the target, the first step is to get in the machine. Over the past years, Turla have used techniques such as spear phishing emails or man-in-the-middle attack, probably at the ISP level, but this is not what we have observed recently. Since 2018, the main cause of compromise are improperly cleaned network and watering hole attacks. The former is quite common as it is a challenge to totally clean a network once compromised with Turla. Watering hole attacks, also known as strategic web compromise, consist in compromising websites that are visited by the person you want to infect. In the case of Turla, selected visitors are redirected to a fake flash update page controlled by the attacker. This is the summary of the last watering hole attack that happened in 2019. They compromised several websites related to Armenia, and the second one is interesting because this is the Ministry of the Republic of Artsakh, and this is a region where a war took place this fall between Armenia and Azerbaijan. On those websites, they added a piece of obfuscated JavaScript code that is responsible for loading a fingerprint script from the CNC server. So this fingerprint script will send back to the CNC server some information about the visitor. Then, if the visitor is deemed interesting, we believe that this is a manual choice by the attacker, they will be redirected to a fake flash update web page. Then the visitor needs to manually click on the link to download the fake flash update and manually execute it. So there was no exploit involved. Then, once he has executed the fake Adobe Flash update application, a Turla malware will be installed. Before September 2019, it was Skipper, which is a well-known Turla first stage, and then they switched to newer malware families we call NetFlash and PyFlash, PyFlash being a custom Python backdoor. As the main goal of Turla is to stay undetected for a long time, generally months or years, they have a few implants dedicated to this task. Today I choose to present three of them. The first one is LightNeuron. It persists as a Microsoft Exchange Transport Agent, which is a plugin system for the Microsoft Exchange mail server, and it's generally used by anti-spam products. It allows full access on the email traffic, as it allows to set up callback on events such as when an email is received by the mail server. So this is a summary of how the backdoor part of LightNeuron works. So this is a passive backdoor, and in that case, I will present a case where the Exchange server is already compromised by LightNeuron. This is not how they first enter the network and compromise the mail server. I'm presenting how they can execute command on the server. So Turla operator will send an email to any email address of the compromised organization, and they will add a specially crafted attachment. Then this email will be received by the Exchange server. As LightNeuron is installed as a transport agent, one of its callback will be called. So LightNeuron will process the email, check the attachment. If it's a PDF or a JPEG, it will check if there is a specific signature. If the signature is there, it means that it's an email that was created by a Turla operator. So it will extract encrypted data, decrypt it, and this decrypted data is a command to execute, and the command will be executed. So this is a passive backdoor, meaning that LightNeuron is never reaching out to a CNC server, but this is the controller. A Turla operator is directly sending commands, and commands are executed. The other function of LightNeuron is to modify legitimate emails. So as I said before, it has access to the full email traffic of the compromised Exchange server. So let's imagine that someone is sending a legitimate email to anyone in the compromised organization. So the email will be received by the Exchange server. As before, it will be processed by LightNeuron. Then it will apply some rules. So these rules are defined in XML, and they are tailored for each victim. So there is a rule engine in LightNeuron, and it uses logic operators such as and, or, and conditions on specific fields of the email can be specified. For example, to field or from field. And based on that, LightNeuron will take some actions. So actions can be modify the email, block the email, do nothing, and also dump the email on disk. So in case of modification, it's quite powerful, as we can imagine that LightNeuron can be used to add some 0-day in an existing Word or Excel document, and then it will be delivered to the final receiver. Finally, there is another version of LightNeuron called NetTrans. It's fully in .NET. LightNeuron, there is one module in .NET and also one module in C++ for such things such as the rule engine. But in NetTrans, it's fully .NET, and it implements only a subset of functionality. So if you want more information, please check our white paper. You have the link here. Now let's jump to the second long-term implant, which is Comrade version 4. This is the descendant of agent.btz, which was the worm used against the US military in 2008. It has been extensively analyzed. For example, there are publications by GData from several years ago. This version 4 is in full C++, and it uses several design patterns, so it shows the level of professionalism of its developer. It persists using a PowerShell loader based on the open source project PowerSploit. One of these distinctive feature is its virtual file system in FAT16. This is not the first time Turla uses a virtual file system. For example, there is one in the Snake rootkit. But so in that case, on this is a regular file, but once decrypted, it's a FAT16 partition. It contains several folders. For example, there is a configuration for the command control channel that uses email in /etc/transport/mail. And if we open the cookie.str file, we have access to the cookies that will be used to connect to the Gmail web interface. There is also configuration for the HTTP network protocol and also log files. There is one called working.c4log, C4 standing for change4, change being the internal name of Comrade. So in this working.c4log, there is a lot of interesting information such as the last commands executed by the backdoor. The second distinctive feature of Comrade are its CNC communications. So the first CNC channel is called Legacy, and it is an exact copy of the Comrade version 3 protocol. We believe it is intended to be compatible with old CNC server, avoiding the need for the operator to redeploy a full network infrastructure. The second command control channel uses the Gmail web UI, and it is an asynchronous email protocol. By asynchronous, I mean that operators are sending commands that can stay in the Gmail inbox, waiting for the backdoor to connect to the Gmail inbox to retrieve it. Also, what's quite funny is that it embeds the HTML parser called Gumbo, which is also developed by Google. So first, the Turla operator sends an email with a specially crafted attachment to a dedicated Gmail mailbox. So these mailboxes are created under the full control of Turla operators and are not compromised mailboxes. However, they generally mimic the name of an employee of the compromised organization in order to be more stealthy. Then the compromised machine will connect to this mailbox using the cookies I showed you earlier. It will check for new emails. So this is an example of an email. For the sake of the example, it's displayed in Outlook, but theoretically it's in the Gmail web interface. We can see that the email was sent from another free email provider called GMX. And there is also an attachment. It is actually not Excel files. There is just the extension, but it's actually encrypted raw bytes. Then Comrade will parse the HTML of Gmail in order to retrieve the link to download the attachment. It will download the attachment, decrypt the content, and execute the commands. So this is an example of a set of commands sent by the attacker to Comrade. In this case, the application acpvt2.exe is the WinRAR application. So first, they will compress some data. Then they will mount cloud storage, a OneDrive cloud storage. And then they will copy the compressed data to this cloud storage. So it is quite interesting to see that they are using another network channel to transfer stolen data, and they are not using the command control channel Gmail. This second example, this is very similar, but this time they are using RPC backdoor, which is contained in the PowerShell loader kcl.ps1. So RPC backdoor, it's used to execute commands on another machine of the local network. And the name of the local machine is specified in the IV key variable. So as before, they will compress some data, then they will mount the cloud storage, and then they will copy the archive there. So in that case, the storing data isn't even going through the machine compromised with Comrat, but it is directly going from the other local machine to OneDrive. If you want more details, for example, about the command control protocol, please check our white paper, again on our blog, welivesecurity.com. And now let's jump to the last long-term implant, which is Crutch. It was previously undocumented. As this talk is recording, I'm not sure if the white paper will be available before or after BotConf, but you can check on our blog. So Crutch is a toolset mainly used to collect documents, and it uses Dropbox as a command control server. According to our visibility, it was active from 2015 to early 2020. And as you can see at the bottom of this slide, Crutch is the name given by its developer. So Crutch was never publicly attributed to Turla when we found it, so we had to identify a few elements that allowed us to make the attribution. First, on the same machine and at 5 days of interval in September 2017, Geyser, which is another Turla backdoor which was attributed several years ago to Turla, was dropped at the same location as Crutch in C intel upd.exe. Secondly, the dropper and loaders of Crutch and Geyser are very similar, so PDB paths are very similar. They both use a cap file, and their loaders are using the same encryption key, or RC4 key, to load the final payload in memory. It's also interesting to note that another group, the Dukes or APT29, were also there, and the malware components are linked to what we call Operation Ghost. So Crutch persists using DLL hijacking. This is not something we see often with Turla. So they hijack Chrome, Firefox, OneDrive, and more recently an old Outlook Finder executable. Also, there are several versions. The last one, the V4, having been released in July 2019, and in that new version, for some reason, they remove the backdoor functionality. So this is a summary of Crutch functionalities. So first, the backdoor part, which is available from version 1 to 3. So Turla operators, they can upload comment to the Dropbox account in the form of a fake zip archive. So only the few first bytes are the zip header, but the remaining part of the file are a custom format of Crutch. So they will upload it to a dedicated Dropbox account, which is, as the Gmail accounts, they are created under full control of the attacker. They are not compromised accounts. So on these accounts, we can see there are a lot of fake zip files with very generic file names. So the compromised machine with Crutch will reach out to the Dropbox storage and then download this fake zip, decrypt them, and execute the command. So this is an example of decrypted fake zip. So the first byte is the command ID. In that case, it's 3. It means drop the file on disk. We now have the path where the file will be written, and we can see the content of the file, the beginning of the content. The two first bytes are MZ, which means that it is a Windows executable. So now the document harvesting part, which was in all versions of Crutch, including the last one. So it monitors local drive, but also every time a removable storage, such as a USB key, is plugged in the computer. So it uses a WinRAR application. It's called ehlp.exe on disk. They will compress files that are newer than 7 days from this USB key. So for example, PDF file, doc file, Excel, etc. So once they have this archive, they will upload it to Dropbox. In So in case of the Crutch version 4, it is directly uploaded on Dropbox, and in case of version 3, it's first being put in a fake RAR archive, so there is a second layer of encryption, and this fake RAR is very similar to the fake zip. It uses the official Dropbox HTTP API to upload the file. There is a token to authenticate to Dropbox, and it's encoded in the malware samples. And then the Turla operators can just download this archive from Dropbox. So we monitor, we had access to some of the commands executed by Crutch, and we noticed that at some point they drop a recovery backdoor we call service DNS. It's a simple bash script that persists using a Windows sidebar gadget. So this is the main code of this bat file. You can see that it does a DNS query of type hinfo to the CNC server. DNS query of type hinfo should return hardware information about the server, but in that case we try and it returns a URL. So that's kind of interesting. We queried this URL and it returned a command. So it means that the DNS hinfo is the command control channel to receive commands for this recovery backdoor. And this is not a technique I saw before, so it was new for me. So finally, some recommendation. So use complex unique password and two-factor authentication. It may sound that very simple, but this using stolen credentials in the main way Turla used to move laterally on a network. They also use a lot of PowerShell, so whenever possible, you limit or forbid PowerShell execution. And finally, they have several tools such as RPC backdoor or hyperstack that is used with the Carbon framework to manage machines the local network using pipes. So if it's possible, it's better to limit communication between local machines. Then after a compromise, make sure to clean and reinstall all machines. As I said at the beginning, they generally just keep a foothold on the compromised network. They won't need to use exploit or anything to reinfect the network. They just reconnect using credentials they've stolen before. So change all the password, review the list of accounts, because they generally create new accounts that they can then come back using, for example, RDP. Finally, they generally move to the Active Directory server and also mail server. So this is the first thing to clean, because if you change all password but there are mimikatz on your Active Directory, it's kind of useless. So to conclude, there are very few headlines about Turla compromise, but a lot of high-profile organizations such as governments are targeted or were compromised by this group. Also, they tend to attack always the same targets and can stay in the same network for months or even years. And basic hardening can complicate much of their operations. And they will make more mistakes if it's harder for them. Thanks for your attention. Feel free to ask questions.